Hi guys, in today's video we're going to take a look at more exponential equations, specifically population growth. We talked about the exponential formula in last night's notes, the y equals a times b to the x, and we're going to look at that some more today in terms of population growth. So this is the formula we talked about yesterday. This formula right here, y equals a times b to the x, where the a value is our start, or it's our initial value. Where are we starting out with, and b is our growth factor. So let's take a look at b real quick for a second. B has to be bigger than 1, because if it's 1, then nothing's changing. If you multiply something by 1, you just get the same thing. And if it's less than 1, we're going to get smaller numbers. So our growth factor, b, is always equal to 100% plus the amount of the percentage of growth. So for example, if I said it was increasing at 3% each year, our growth factor would be 103%, because we have to include that initial population. So again, the growth factor is 100% what the population is currently plus the percentage growth. So what the population is currently plus the percent of growth. So let's take a look at the Aussie rabbits. In 1859, a small number of rabbits were introduced to Australia by English settlers. The rabbits had no natural predators in Australia, so they reproduced rapidly and quickly became serious problems for the sheep, cattle, eating the grasses intended for them. Think of a growth factor in terms of a percent change. For example, suppose the yearly growth factor for a rabbit population is 1.8. If the initial population is 100 rabbits, that means that there will be 180 rabbits at the end of the first year. So the change from 100 to 180 is 80%. So it would be an increase of 80 rabbits, and since 80 rabbits is 80 out of 100, we can call that 80%. So this growth factor of 1.8, it's 100% plus the 80% increase. And that's where we get, and this 80% is our growth factor. So the growth factor of 1.8 comes from keeping the 100% of the previous population of rabbits and then adding 80% each year. So 100% plus 80% is 180%, and written as a decimal, that's 1.8. That is going to be our B, or our growth factor. So let's take a look at example 1 over here. If we have 3 growth factors, we have a growth factor of 105, we have a growth factor, of 1.05, of 1.25, and we have a growth factor of 1. So for A, this means a growth factor of 105 means 105%. So that means 100% plus 5%, and this 5% is our growth rate. Same thing for letter B. In letter B, we have 1.1 as our growth factor, and that means 110%. So it's 100% plus 10%. So our growth rate is 10%. And finally on letter C, I did that backwards. This would be letter B, and this is letter C. It's 1.25, which is 125%. So that's 100% plus 25%. So our rate, our growth factor is our percent change. So in letter A, the percent change was 5%, letter B, it was 25%, and letter C, it was 1%. So now back to the rabbits. We need to write a now-next equation to represent the growth of rabbits. So we know that we started with a population of 100 rabbits. The growth rate, our next, equals now, our growth factor is 1.8 because it's increasing by 80% each year, and this includes, this is the 100% of the initial population, and this is the 80% growth rate. So now we need to write an explicit equation. So for explicit, it's y equals a times b to the x. A is our start. We're starting out with 100 rabbits. B is our growth factor, which in this case is 1.8. X is the number of years. And Y is the population of rabbits. So if we fill in what we know, Y is the population. We started out with 100, and that's times 1.8 to the X. That's the equation we're looking for. So to put that equation into practice, if the growth pattern continues, how many rabbits will there be in 4 years? So if X is 4, and in this case it's years, I want to know what Y is. So same equation, Y equals 100 times 1.8 to the X. We're taking out X and we're plugging in 4. That's this 4 right here. And when we get down to our Y equals, it's about, and we're going to round, 1,050. And it's 1,050 rabbits. So let's take a look at one more example real quick, and this one is not on your notes. Let's say, for example, that we will go with the same population of rabbits. We start out with 100 rabbits, and let's assume that there was a drought or something, so the rabbits were increasing by 25% each year, and this would be an increase of 25% each year. So we know what our start is. Our initial value is 100 rabbits, and our growth factor is the initial population, which is 100%, plus the percent increase, which is 25%. So they're increasing, or their growth rate is 125% each year. And to write that as a decimal, it's 1.25. So if we want to write an equation for this, we get Y equals 100, which was the initial population, times 1.25 to the X. And again, this 1 includes our initial population. This is our initial 100, and that's 100% of all of this right here, and this is their growth rate per year, or their increase per year. Okay, so let's take a look at this example. A town with a population of 5,000 grows 3% each year. So we need to know what's our initial value, what is A equal to, and what is our growth rate equal to. So A is our initial population, and B is our growth factor. So for question 1, it's asking you what is the growth factor, what is B equal to, and keep in mind you have to, it's increasing by 3% each year, but you have to include that initial 100% of the population. Question number 2, find the population at the end of year 10. So you're going to need your y equals equation, and in this case you're going to let x equal 10 in your equation. So don't forget to enter your answers on the Google form that's located on my website. And if you have any questions, please include those as well.